This is a movie for learning target number 5, Inequalities in One Triangle. Alright, there's some supplies at the top or at the table in the front of the room. I ask that when you pick these up that you do not bend the pipe cleaners because I need them for all my classes. You're going to need a protractor, a long ruler, and then 1 red, 1 blue, 1 green, and 2 yellow pipe cleaners. Pause the movie, go get those supplies. Do not bend the pipe cleaners. Press play when you're finished getting those. All right, so you are ready. I would like you to use those pipe cleaners. You have different colors of different lengths. And I want you to think about this idea. Given any 3 side lengths, can you make a triangle? Is it possible? And I would like you to use the pipe cleaners to investigate this question. And then once you investigate it, try to get into detail. If you can make a triangle given any 3 lengths, state why. And if you can't, is there a relationship that has to happen in order for you to be able to make a triangle? Pause this movie, investigate, press play when you're ready. Okay. So you probably noticed with the different colors, the red I actually made 12 inches long. The 2 yellows are both 6 inches, 6 inches. The green was 4 and the blue was 3. So I don't know if you noticed, were we able to make a triangle with any of the pieces, including the red? And the answer to that is no. Even if we put 2 yellows next to each other, the second longest pieces, it would lay flat because the 2 yellows added together give us the exact same length as the red. So it's not giving us any lift to form a triangle. Instead, it's laying flat. But you could make a triangle with a yellow, a green, and a blue. We could put those together, and we get a triangle like this, ABC. So, given 3 side lengths, you could make a triangle, but it's not always possible. So, given any 3 side lengths, can you make a triangle? And the answer is no. Not any 3 side lengths, only certain ones will work. And here when we notice with the 2 yellow, if I add up 2 side lengths, they cannot equal the third. And if I replace the yellow with the blue, if I add up these 2 side lengths, it obviously doesn't work. So, and that's because it's even shorter than the red. So I need to be able to add up the 2 side lengths and get something greater than the 3rd side length. And that's going to determine if we can make a triangle or not. We're going to get to that in a minute. Next thing I want you guys to notice. We're going to pause this, keep this triangle, the green, the blue, and the yellow on your desk. We're going to come back to him in a minute. All right, so we know that 14 is 6 plus 8, right? So if I took 14, what's my relationship between 14 and 6? Well, we know 14 has to be greater than 6 because I took 6 and added something to it to get 14. So if I know that A is equal to B plus C, and I know C is not 0, see up here, 8 was not 0, then I know that A has to be greater than B. I know that sounds a little silly, but we're going to add that idea to our purple sheets. It's called the comparison property of inequality. It says if A is equal to B plus C, C is greater than 0, then A has to be greater than B. So if I took a number like B, added something to it, I'm going to end up with something greater. And that's what this says. Pause the movie, add this to your purple sheet, press play when you're finished. We're going to skip the proof of that. We're going to go straight to how it relates to what we're doing. Corollary to the triangle exterior angle theorem. If you forgot what the triangle exterior angle theorem said, it said that given this picture, the measure of angle 1, the exterior angle, which forms from taking a side and extending it, this angle is equal to the sum of the two remote interior. If I add these two angles inside, I get what the exterior angle is. Now the corollary says that the measure of an exterior angle of a triangle has to be greater than these individual angles inside. So if angle 1 is an exterior angle, then angle 1 is greater than 2, and angle 1 is greater than 3. Pause the movie, add this to your purple sheet, press play when you're finished. If we apply that corollary to this image, use the figure to state why angle 2 is greater than the measure of angle 3. Pause the movie, try to figure this out, press play when you're finished. If we look at triangle DBC, see these two marks? That tells me that those two sides are congruent. And if those two sides are congruent, this is an isosceles triangle. That tells me that the measure of angle 1 and the measure of angle 2 must be the same. So I set them equal, and that's because of the isosceles triangle theorem. Now I also notice that if I took AB, and I extend it, 1 is an exterior angle to 3 and 4. So I know that my exterior angle, angle 1, is equal to the sum of the two remote interior, 3 and 4. So 1 is equal to 3 plus 4. That's my exterior angle theorem. Now, I also know 1 is congruent to 2, so I can take out 1 and replace it with 2 by substitution. That tells me 2 is equal to 3 plus 4. This angle 2 is equal to these two angles added together. So that tells me, using that corollary, that if 2 is equal to 3 plus 4, then the measure of angle 2 has to be greater than the measure of angle 3. And that's the reason why, because of that corollary. If you were to write a paragraph about it, you could state this. Now, I'm going to go back to this triangle that we had. Here he is. I want you to figure out which of these three angles is the shortest to the longest, and I also want you to do the same with the three sides. List the sides from shortest to longest. Pause the movie, list both the sides and the angles from the shortest or the smallest to the largest or the longest. All right, let's look at the sides. We know we've got BC's the shortest, then AC, and then AB. Now, if we're looking at the angles, we can see that the smallest angle here is angle A, then angle B, and then angle C. Now, what I want you to notice is that I've got angle A, and that is directly across from side BC. So, that tells me that my smallest angle is across from my shortest side. Look at the largest side, the longest side, AB. What do we notice about C? We see that C is our largest angle. So what this tells us is that the shortest side is across from the smallest angle, and the longest side is across from the largest angle. Now we're going to write that down on our purple sheets. It's Theorem 510, and it says if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. And we just saw that. So pause the movie, add this to your purple sheets, and press play when you're finished. Let's look at this. A town park is triangular. A landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? Press pause and play when you're finished. Okay, we can see that of the three sides, 175 is the longest side. So the angle that's the largest has to be opposite that. So we are looking here at this angle. So that tells me Hollingsworth Road is the longest street, so opposite MLK Boulevard and Valley Road is the largest angle right here. Now this is sort of the converse to what we saw before. It says if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So pause the movie, add this to your purple sheets, and press play when you're finished. There's a proof for it that we're going to skip. I would like you to look at this one. Which choice shows the sides in order from shortest to longest? In order to analyze the sides, we need to know all the angles. So how do we get angle T? See that we've got angle T is going to be 60 degrees. So when we're looking at shortest side to longest, we can see that the shortest side is going to be opposite the smallest angle. So our shortest side is actually going to be TV. And the ones that start with TV are this one, so not that one, and that one. So A and D, it's between A and D. Our second smallest angle is 60, and that's opposite the second longest side. So the next side needs to be UV. This has UT, so that one's out. It looks like A is in the makings. Let's just test the third one, and that is that 62 is our largest angle, and it's opposite the longest side, TU. We can see that that works. So we've got the largest angle opposite the longest side and the smallest angle opposite the shorter side. All right, we saw back here at the beginning that when we had a triangle, not just any triangle was made by any three lengths. For example, here I've got 3 and 3, which give me 6, and you can see that that helps make this triangle. Here, if I've got a 6 and this is 2 and 2, you can see it does not form a triangle because 2 plus 2 is 4. That's less than 6. So what must be true about the side lengths of a triangle? And then how can we determine if the lengths can form a triangle? Pause the movie, answer this question, press play when you're finished. Okay. We know that the sum of any two sides must be greater than the third side in order to make a triangle. Like here, 3 plus 3 is 6, and that's greater than 5. Here, 2 plus 2 is 4, and that's not greater than 6. So how can you determine if the lengths can form a triangle? We just find the sum of each pair of sides and verify that the sum is greater than the third side. So let's do that. We have the triangle inequality theorem. It says that the sum of any two sides must be greater than the third. So pause the movie, add this to your purple sheets, press play when you're finished. All right, can a triangle have sides with the given lengths? Explain. Let's look at 3, 7, and 8. If I take the three different variations, 3 plus 7, and see if that's greater than 8. We see that 3 plus 7 is 10. 10 is greater than 8. That's a true statement, so that works. Let's look at the second variation. If I took 7 plus 8, and that has to be greater than 3, because the sum of any two sides has to be greater than the third. So I add these, I get 15. 15 is greater than 3, so that works. And then the last variation is 8 plus 3. And seeing if that's greater than 7. We see that it is. 11 is greater than 7. So yes, the sum of the lengths of any two sides is greater than the third. Try it with this one. Pause the movie, try this one on your own. Okay, so if we test this out, we have 5 plus 10 is equal to 15. Because it's not greater than 15, we cannot make a right triangle with these. So that does not work, because the sum of any two sides has to be greater than the third. We explored the possible dimensions of a triangular sandbox. Actually, we didn't. Two of the sides, 5 and 8. What's the possible range for the third side? So if you're given side lengths, 5 and 8, we've got 5, 8, but we don't know what the third side is. So I'm going to set it equal to x. Now, I know that the sum of any two of these has to be greater than the third. So if I let x represent that, I'm going to have three different scenarios. I know x plus 5 has to be greater than 8. I know x plus 8 has to be greater than 5. And I know 5 plus 8 has to be greater than x. So I'm going to test each of these out. If I solve this inequality for x, I subtract 5 on both sides. I get x greater than 3. Here, if I subtract 8 on both sides, I get x greater than negative 3. And here, I get x is less than 13. Now these three scenarios have to all be true in order for us to get our range of possible values. So x has to be greater than 3 and x has to be greater than negative 3. So we can see that this idea of x being greater than 3 takes care of this one, x being greater than negative 3. So we really don't even need to pay attention to this one, only because x being greater than negative 3, this takes care of it, x having to be greater than 3. Here, x has to be less than 13. So, to get our answer, we say that the numbers satisfy x greater than 3 and x greater than negative 3 must be greater than 3. So the third side must be greater than 3 and less than 13. We can write that as x has to be greater than 3 and x has to be less than 13. Pause the movie, try this one on your own, press play when you're finished. We've got 4 and 7 and x. Our three scenarios give us 4 plus 7 greater than x, 4 plus x greater than 7, and 7 plus x greater than 4. Solving each of those for x, I get x has to be less than 11, has to be greater than 3, and it has to be greater than negative 3. Seeing this scenario, I don't need this one because the x being greater than 3 takes care of that. So I get that 3 is less than x is less than 11. And that's the end to learning target number 5.